Now, one of the things that's really important to understand is that if you need to perform maintenance on one of your storage arrays, and that storage array is going to go offline, making virtual machines that are on that data store unavailable to ESXi, meaning those virtual machines can no longer run, okay, then you need to do something about this before you take that storage array with those data stores offline. The first thing that you need to do is make sure that all of the virtual machines that were running or located on that data store are either powered off or they are storage vMotioned to another particular storage array. Once that's done, you can take a data store and enter maintenance mode by right-clicking on the data store, going to the maintenance mode link here, and selecting Enter Maintenance Mode. At this point, you can use storage DRS if you're running in a data store cluster, for example, to automatically storage vMotion the virtual machines away, or you could have done it manually beforehand. But what maintenance mode on a storage array does is ensure that no ESXi host needs anything on that particular data store. Once that's done, you can feel free to power off that storage array, remove or destroy that data store, whatever you need to do. Finally, we come to the topic of deleting and unmounting VMFS data stores. Now, these are actually two different actions that you can do if you want to be rid of or simply remove from access a data store to an ESXi host. So right-click on a data store, unmount or delete that data store. Unmounting it removes it from access to ESXi hosts. Deleting it for a VMFS data store is actually destructive of data. Either way, you have to make sure that there are no virtual machines on that data store, whether they're powered on or not. If vCenter or ESXi sees that there's a virtual machine on that data store, it will not allow you to delete or unmount that data store. Now, when it comes to multipathing for iSCSI or for Fiber Channel, there are a couple of different ways that we can enable multipathing on the software level to those data stores. We already talked about how to do it on the hardware level, right? And add a couple of HBAs to your ESXi hosts, enable 2 VM kernel ports, each with a physical adapter, and so on. But when it comes to choosing which of the paths ESXi will utilize to access a particular data store, then it comes down to which multipathing algorithm do you want to use? Now, ESXi has a few built-in multipathing algorithms, but your storage vendors may have a plugin that will allow you to install a third-party multipathing algorithm into ESXi. The way that we configure this is by selecting your data store and going to the Configure tab. You'll notice here that you see an icon that says Connectivity and Multipathing. Down here you have a button that says Edit Multipathing Policies. Now there are 3 built-in or native multipathing policies that are available to us. For scalability purposes, that is, I want to enable more bandwidth between my ESXi hosts and their NICs or HBAs and the data store itself, I can choose round-robin multipathing. By default, what round-robin will do is send 50 commands, SCSI commands, up each of the available paths in order, and it'll go round and around and around. Doing that across multiple ESXi hosts to the same data store will actually enable a significant, nice distribution of the data across all of the paths from your ESXi hosts to the storage array itself. Now, there are some hardware vendors on the storage array side that may ask you to adjust that 50 commands to say one command. For every command, bounce back and forth between them. And that's fine. Follow your vendor's recommendations, and that is typically done on a command line basis, but your storage vendor will instruct you on how to do that. Now, that round-robin scalability method is only available if your storage array itself is capable of what they call active-active load balancing. In terms of availability, if you're not interested in the scalability aspect of round-robin, back and forth and back and forth, you simply may be interested in ensuring that there are no single points of failure between your ESXi hosts and your storage arrays. In that case, you're going to choose either most recently used as a storage policy or fixed as a storage policy. Most recently used is the one that is used for storage arrays that are not capable of active-active multipathing. Most recently used will choose the first path available and always use that path until there's a failure, at which point it'll switch to another path that happens to be available. And it will continue to use that path until there's a failure, at which case it'll look for another path. Even if that first and original path becomes available. With most recently used, it will not fail back. That's the difference between MRU for most recently used and fixed, which requires an active-active storage array. With fixed, it will choose a preferred path. If there's a failure in that preferred path, it'll fail over to another path. But if that preferred path becomes available again, it will automatically fail back. So that's the difference between most recently used and fixed. And once again, you can choose that multipathing algorithm by selecting the data store, going to Edit Multipathing, and this pull down allows you to choose from among the native multipathing plugins that are included with ESXi or any third-party path selection plugins that you might have installed separately. So that does it here for lesson number 4. When we hit the lab at this point, we're going to do a number of exercises to show us how easy it is to both create a VMFS data store and to modify a VMFS data store. We'll start by creating the VMFS data store. We'll expand that VMFS data store to use more of the LUN that happens to be available. We'll then delete a VMFS data store. We'll then create a new data store that, or we'll extend a VMFS data store, and then we're going to create a second VMFS data store where we're going to actually put a bunch of virtual machine files. So that does it there for lab number 13. Please go and enjoy that lab, and this brings us to the end then of lesson number 4, where we've built some VMFS data stores, we've increased the size of a VMFS data store, we looked at data store maintenance mode, and we also learned how to delete a VMFS data store. Now when we come back, we're going to have a look at NFS data stores. See you soon.